Hi everyone, and welcome back to Royan Study Corner. I am Royan, and today we're going to be learning all about scales. And no, I am not referring to the scales that we stand on to see if we're weighing 130 pounds or 150 pounds, but I'm referring to, well, we'll see when we get into it. So it's about reading scales. You're in Form 4 or Form 5 or most likely Form 4 now. So you're going to start doing labs. And when you're doing labs, remember a lab is essentially an experiment. If you're doing an experiment, you're going to have to be taking, I feel like what I just said made no grammatical sense, but you're going to be taking readings from apparatus. So whether it's a measuring cylinder, whether it's a thermometer, whether it's an ammeter, you have to be able to look at it and take the reading correctly, otherwise everything will go haywire and all of your calculations will be off. So I'm saying so again. And while a lot of us think that comes easily, it's actually something that you should get more practice with, and it will make everything a little bit easier and you'll be able to take readings a lot more quickly. Now, let's get into it. As I said, today we are learning about reading scales, and you see my cute how I'm doing my new PowerPoints now. I really like it. I don't know. So reading scales, what are we going to learn and what are our I can statements? So we're going to learn what a scale is. So at the end of this video, you would be able to say I can define a scale, meaning I can say what a scale is. You are going to differentiate between linear and non-linear scales. So at the end of this video, you're going to be able to say I can differentiate between a linear and non-linear scale. You will also be able to differentiate between an analog scale and a digital scale, which we'll remember from clocks and digital watches, and how to read analog scales, because a lot of the apparatus that you're going to be using will have an analog scale. What is a scale? A scale is a set of marks at intervals on a measuring instrument. So we're not referring to a scale that you stand on. The scale is literally just the set of marks on the instrument that you take your reading from. Types of scales. One of the ways that we categorize scales is by saying linear versus non-linear scales. Linear scales, all of the marks are equally spaced, and each space has the same change in values. So if we look here on the ruler, all of the spaces are the same distance apart, and the number you see by each one of them, it just increases by 1, 0, 1, 2, 3. And the ammeter underneath, you will see 0, 5, 10, 15, 20, which means they are equally spaced, and each of these spaces increase by the same amount, in that case by 5. The other type of scale is a non-linear scale. Now these, the marks are not evenly spaced, and the changes in between each mark is not equal. I know a lot of people have not seen things like these, but you will see them as you progress, don't worry. We can see here an ammeter where the spaces are not the same distance apart, and by one marked reading you see 0, by another marked reading you see 100, and by the next marked reading you see 150. So there isn't the same increase with each mark. There are other types of scales now that things can be divided into. One is the analog scale and the other is the digital scale. Analog scale. This is just like the clocks where you have to count and go around. So the pointer would continuously move just like the second hand, minute hand, hour hand on a clock, and it usually has equally spaced lines. Remember, usually, not all the time. A digital scale, the reading does not vary continuously. The last number will just change. So just like your alarm clock that you may have at the side of your bed, the last number will just change every time. It's not going to, all of the numbers aren't going to change continuously. how to read linear analog scales. There are 3 basic steps that you need to keep in the back of your mind. And once you've read enough scales, then you don't even have to remember these steps anymore, because it becomes like ingrained in your mind and you just do it without realizing. So the first step, find the smallest division of the instrument. The second step, find the unmarked readings. And the third step is to approximate between divisions. Let's go on to the next slide and we could go into that more in depth. So we have our ruler here, and we have each of these steps here broken down. We have find the smallest division on the instrument, find the unmarked readings, and approximating between divisions. We have our ruler here. Let me drag it up to the corner, make it a little bit bigger. Okay, I now realize I wasn't recording that part, but you'll see it now big at the corner. So our first step is to find the smallest division. What does that mean? It means that we're going to find 2 readings, usually 2 readings that are next to each other. It will work out even if you choose 2 readings that are not next to each other, but 2 next to each other. So you take 2 marked readings that are next to each other. So I will choose 1 and 2. So we have our 2 marked readings. The next step tells us to count the number of spaces in between them. So let's go. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 spaces. So the smallest division is the difference between those 2 marked readings. So since we chose 2 and 1, 2 minus 1 divided by the number of spaces in between them, which we just counted as 10. So 2 minus 1 is 1 over 10, which means each space is 1/10 or 0.1. And our unit here is centimeters, so I'll write centimeters. So that is our smallest division. Our next step is to find the unmarked reading. All that this means is that we're going to count, and let me get the eraser and erase these lines that I just drew up here. If we know that each spot or each space is 0.1 centimeters, it means we can count all of them. So we start at 1 and we count with our spaces. So 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, and 2. So then we could easily count and know which space it is. So if we had something that whose length was coming, and let's say it started at the end here and came all the way down to here, then we'd be able to count and say, okay, that's 1, 2, 3, 4 spaces. So then that will be 1.4 centimeters. The next step, which doesn't apply in every single case, is to approximate between divisions. This is if something lands, let me change color and see if something lands in between one of these spots here. So let's say it went from here to the end. So it doesn't land exactly on a line, then we have to approximate. This is where we're going to use our discretion and look at the space and see how many spots we can divide that into in our mind to average. This is tiny, so I would divide it into 2. So we could say 0.1 divided by 2, and we get 0.05, which means in this instance I would just count, and when I see, okay, that's 1.1, 1.2, 1.3, 1.4, and then I would add that. So that would be 1.4 plus 0.05, which would give me 1.45 centimeters. And that's it. Easy peasy, according to my niece. Now, let's try another example. Here we have, this is another one that we looked at before in the examples when we were looking at linear scales. So we don't have anything, the indicator here is pointing at 0, so we're not making an accurate measurement, we're just trying out the procedure to see if we get the same thing. So our first step again is to find the smallest division. Now let's choose 2 random numbers. It could be any marked numbers. Usually I use numbers that are next to each other, but it will work either way. So let's try it with using numbers that aren't next to each other to work it out. So we'll have, let's choose 5 and 15. So 15 minus 5, and the number of spaces would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 spaces. So we're not using numbers next to each other like 5 and 10. We're using 5 and 15. 15 minus 5 gives us 10, and 10 is our denominator, so 10 divided by 10 is 1, which means that each space is 1 amp, and we can count that to see if it makes sense. So we can say 5 and 1 would give us 6, so 5, 6, 7, 8, 9, 10. We see it works up until 10. 11, 12, 13, 14, 15, which means that each space is 1 amp. Our next step is to say find the unmarked division. So if it was if we had the pointer pointing here, let's put it in the middle here, we would say 5, 6, 7. So 7 is the nearest line. But then our third step is to approximate in between divisions. So I'm just going to divide into 2 because I find that's always the easiest to go with, rather than trying to divide a tiny space into 4 or 5 or 10 or something like that. So if each space is 1 amp, then half of each space will be half of an amp, or 0.5 amps. So if the indicator is by this green line here, it means that would give us 7.5 amps. And that's it. So it's really very simple once you get into the swing of it, and then as soon as you look at a scale, you'll be able to read off the value just like that. I promise you that. So here are some questions that you can practice. We have 5 questions here. All of them are linear analog scales, and all of them have the pointer, so you don't have to make up some indicator like I did here. All of them have the pointer pointing to a number, to a line, or in between a line. So try them and see if it gets a little bit easier by maybe the third one, I would guess. So that is it for today. We looked at how to read scales, all of the little steps that you work out in your mind. You can work them out on paper for now, but as you get better, you work them out in your mind. And that's it. So thanks for watching. I'll see you all in the next video. Remember to stay safe and be kind to yourselves. Thanks again for watching. See you next time. Bye.